Hey everyone, welcome to On Track, an ongoing video series where we cover hot topics in PCB technology and designer interests. My name is Andy, and I'll be your host as we dive into PCB industry trends and emerging developments. We've been talking a lot lately about the Internet of Things, IoT, and its impact on PCB design. This week is no exception. IoT, alongside smartphones, cameras, and wearable electronics, is pushing the industry towards alternative technologies in PCB designs. It's time to learn the design principles behind them. Right now, the global PCB market is growing by leaps and bounds. The burgeoning popularity for IoT products, not to mention smartphones and classic users of PCB tech, has given plenty of fuel to the fire. Flexible PCBs haven't been left out. A rising tide lifts all ships, as they say, and flexible PCBs are following the peaks in demand closer than ever. Estimates indicate that market value will grow from $63.5 billion in 2016 to $73.8 billion in 2021. Flexible PCBs alone will grow to $15.2 billion by 2020 and $27 billion by 2022. In 2014, rigid PCBs slightly decreased in sales while flexible PCBs increased. Presently, the main industry sectors pushing flexible PCBs are IoT and wearable electronics, alongside with flexible displays just over the horizon. These are all applications where space set aside for PCBs is at a premium. Rigid flex PCBs are also well suited for small, cramped spaces. For years, they've been the style of choice for digital cameras, whose wide variety of sensitive components requires both fixed and floating mountings. Camera image sensors require good mechanical isolation, but a high-density interconnection are a hotspot for rigid flex solutions. These boards can fold around corners into origami-like shapes, or over themselves into a layered stack, perfect for passive air cooling. In many of these same spaces, a rigid board wouldn't fit and could induce vibrational issues. Most IoT products and devices have small form factors with cramped, contorted spaces for their PCBs. Flexible PCBs can fill those spaces. Some products themselves are designed to be flexible, making a flexible PCB even more essential. Take smart LED strip light, for example. They need to be flexible alongside their entire lengths for easy and flexible installation. Wearable electronics, where flexible PCBs really shine. Wearable electronics put heavy demands on PCBs that only flex and rigid flex PCBs can answer to. As wearables transition from clunky older designs to more fashionable designs, flexible PCBs will become a necessity. There's more to wearables than the Apple Watch, especially where the next generation of bodywear is concerned. Sensoria's Smart Socks, designed for data-happy fitness enthusiasts, is one such example. These socks literally weave chips and circuits into the fabric, powering motion and step sensors. And then there's the safety wearables, like Shockbox, concussion sensing helmet add-on. A flexible PCB solution, it provided a compact, practical package that would also hold up to repeated heavy impacts. Unsurprisingly, a conventional rigid PCB couldn't stand up to that abuse for long. The IoT might be putting flexible PCBs to the test, but there's one futuristic area that only a flexible PCB could make possible. Flexible displays have been an emerging technology for some time, and it could very soon redefine e-books and smartphones. In 2011, the first prototype smartphone with a fully flexible display was developed with bending actions that could be interpreted as commands. Flexible PCBs power these displays by providing the matrix of transistors needed to drive individual pixels while allowing flexibility. It's a flexible future for PCB designers who know how to work with grid flex. This is On Track. Thanks for watching, and catch you next time.